At harvest time, no two fields are the same. Crop types, moisture content, field conditions, and weather all are important factors to consider when it comes time to get your crop out of the field. Jim Minahan has been following the harvest for over 15 years. He is a harvesting specialist with the customer service group at Case IH. Jim was there when the Axial Flow Combine concept was developed and has been with it ever since. It is our intention in this VISTA program to have Jim share his expertise to help you learn more about setting and adjusting your axial flow to meet your ever-changing crop conditions.
Good morning. My name is Jim Minahan. I'd like to take a few minutes this morning and talk about some combine adjustments, basic, in what we do in setting a combine for wheat. Some of the first things we'll do is check the grain. Look for its quality. How easy does it thrash? Because basically what we do with our hand here, we're going to expect this machine behind us to do the same thing. In studying the grain, gives us a chance to see what its quality looks like. Here, for example, is some pinched wheat. Sometimes they'll stick rather readily in the tip of the wheat when the grain runs out of moisture or from some other deficiency. This crop looks like it may have been developed with a little stress. And these stresses, the machine has to understand in that we may have a white cap like this, for example. It may be easy to thrash, may be hard to thrash. Later on, as we get into the adjustments of the machine, we're going to take a look at these two pieces of the head, the kernel and the white cap, and see what we may have to do to make the adjustments. Not only do we check the threshability of the grain to be harvested, such as this wheat, some farmers will throw a few kernels in their mouth, take a chew. If it chews kind of softly, it's an indication there's high moisture. If it chews rather crisply, moisture is usually a little lower. Most farmers carry a moisture checker right in their pickup so they can take a real quick sample in the field before they start harvesting and have an idea what the grain moisture is before they start harvesting and putting it in a truck. Before we get into harvesting of our crop, there's a few things in adjustments that we'd like to take a look at first. Starting with our header, we're going to talk about the reel to knife auger setting, which is adjusted here with our crank. Also, we have an option, we can do it hydraulically from the cab. Secondly, we'll talk about the adjustment of our fingers, which is controlling this cam, and we'll come back and look and see how the fingers are adjusted when we move this cam. Thirdly, we'll talk about the level of the reel side to side, which is at this point. Before we work on our reel, we always want to put our safety stands down. So if Bill, if you'll raise the one of the adjustments for our reel is fore and aft. We can do it with the aid of our crank or a hydraulic option I mentioned earlier that can be done from the cab. What we're looking for is the attitude of the bats, whether it be a pickup reel or a bat reel, to the knife and auger. We need to get the crop into the knife, hold it while it's being cut, and delivered to the auger. We make this adjustment on either side so that the reel will stay parallel to the header auger, and we do this by checking with a rule. What we're looking for by making sure that the adjustments is equal on both sides is to keep the reel parallel with the header, as well as giving us an idea where the axis of a reel is in reference to the crop, the knife, and our auger. For example, if the reel was too far forward, the fingers or the bats would grab the crop knife get it cut, and it would be deposited in the area in front of the auger, and the auger not get a hold of it until it gets bunched up. Improper feeding. Also, if the reel was too far back, the reel would have gathered the crop, the knife cut it off. More than likely, the reel would have picked the crop up, carried it on over. Further adjustments to the reel is to adjust our finger attitude once the crop has been cut. Normally we look for about a 5-degree tip back of our fingers. If it's too far, it may have a tendency to carry the crop over. If it's not far enough, it may have a tendency to sweep through the crop and we not get it cut properly. And by loosening the adjusting bolt, using a suitable tool, we can reposition our cam angle. What we're going to talk about now is leveling of the reel left to right. Whether it is a pickup reel as we have here or a bat reel, both need to be level with the cutter bar while in operation. To accomplish leveling the reel, we have a threaded portion on our hydraulic cylinders on both sides of the header, as well as this convenient wrench, which is used to raise and lower the reel arms, getting our reel level with our header. Now that we've talked about the major adjustments to the reel, we're going to go further into the header and talk about auger adjustments, which will be the auger clearances and auger fingers. Now that we're going to be working in and around our header a little bit closer, we want to put our safety stand down first before we work on it. With the aid of our cylinder rocking wrench, I'm going to rotate the tube, which is going to reposition the auger fingers. I'd like to have you pay attention to the fingers as they're pointing towards the reel and watch their attitude change as I rotate this pipe several times. This attitude changes the finger timing so I can make it more or less aggressive to the crop. In normal wheat operation in the field, we like to have the auger fingers maxed out at between 2 and 3 o'clock position. And I'll demonstrate in a moment why we want the fingers at this attitude. With the engine of our combine shut down, we're going to take this bouquet of wheat and show you why we want our fingers adjusted at a certain attitude as the combine is going through the field. With our auger fingers timed in this manner, the face of the finger in connection with the tube has an angle such that as it rotates, the wheat will tend to slide off the front of the finger, forcing it back into the reel. What we really like is when the finger is at the 3 o'clock position, you can see the angle of the finger to the auger tube has changed such that we have created a pinch point at the base of the finger where it meets the auger tube. And in this manner we draw the crop to the tube, getting it prepared to go underneath the auger tube back into our feeder chain. Our second auger adjustment is going to be the auger flight to the header stripper. This is to ensure that the crop is fed evenly as the crop is delivered to the feeder house. We want the flight and the stripper to run as close as possible but yet not hit. And to make that adjustment, we will go to either end of the header. To adjust the auger flight to header stripper, we loosen this pivot bolt as well as the 2 adjusting nuts on our eye bolt, which will allow the auger to be moved forward or backward, allowing for the clearance off the auger flight. Our third header adjustment for the auger is the adjusting rod, which moves a wedge front to rear. In doing so, raises or lowers the auger flight off of the bottom or closer to the bottom. Another header option are auger flight extensions, which are used in light fluffy crops to move the material towards the center of the auger, increasing the mat thickness so that the feeder chain can pick it up and transfer it into the combine. To protect the auger on the 1000 series headers, we have a redesigned Belleville washer arrangement inside of a slip clutch housing. We're going to show you how to adjust this if the need ever arises from wear or fatigue. We've taken the liberty at this time to install 2 bolts, top and bottom, into a flange nut which is threaded into the slip clutch housing. With the aid of our cylinder rocking wrench, we can position it on the casting, rotating it 1/8 of a turn, which will increase the driving torque 17 foot-pounds. Now, prior to this, at the factory, we set the slip clutch to be at 180 to 225 foot-pounds. Once the slip clutch torque has been readjusted, the 2 bolts that were used in the flange nut need to be backed out such that the end of the bolt is flush with the inner surface of this support. On the 1000 series headers, we have a unique feature. That feature being that the reel arms with connecting linkage attached to our header auger can lift the auger off the feeder bottom about 2 inches. This feature will allow us to discharge any plugs or slugs that we may have gotten into the header and cause the slip clutch to slip. In a moment, we're going to start the combine up, and we're going to show the driven sprocket, our idler linkage, and our adjusting draw bolt change position. It's important that we have the reel raised completely up prior to making this adjustment so that we have sufficient clearance for the spacer on our adjusting bolt and to follow this important decal. An important point to remember with our auger header lift linkage is that, as this decal points out, is that if we have less than 2 inches of thread showing on our cylinder lift linkage, the pin for the auger lift needs to be in the forward hole, and if there are greater than 2 inches of thread showing, we need to be in the rear hole. On the 1000 series headers, our auger is driven with a 52 sprocket, driving the auger to 170 RPM. This speed is sufficient for most crop conditions, but in the event we get into a light fluffy crop or a crop that does not give us much mass, we can slow our auger down by using a 56-2 sprocket, driving the auger to 150 RPM. This will give us a nice even mat of material into the feeder housing and on back into the separator. On the 1000 series headers, the knife drive belt tension is maintained by this linkage and 2 pulleys with the addition of a tension spring maintaining 5.5 inches of compression. On our headers, we have telescoping PTO shafts, which has a outer protective shield of plastic and needs to be retained at each end while in operation. Also, a small feature is a short stubbed hex shaft, which is used to store the PTO while the header is being transported on a trailer. Now that we've finished our basic header adjustments, reel and auger, we're going to proceed into the feeder house adjustments. With our feeder housing raised and put into the lock position with our safety stands, we're going to continue into the feeder house adjustments. The first one of which we're going to talk about is our lower drum stop, illustrated by the upper decal, and showing 3 positions for our lower drum stop bolt. The bolt is located in this particular area on the right hand side, and there is an accompanying bolt on the left hand side. The reason that we are talking about this adjustment is if we get into some short, dry crop, very low yield, we would take this bolt and put it into its lower position as illustrated here in our decal. With our feeder chain safety shield removed, our next adjustment we're showing is a feeder chain adjusting bolt. This draw bolt positions or correctly tensions the chain so that our lower feeder chain slats are approximately 1/32 to 1/8 of an inch off the bottom of the feeder house. The feeder adapter on our combine is adjustable through 4 slotted holes and adjustable draw bolt to allow for pitch of our knife to the ground for various tire sizes. Another use for our cylinder rocking wrench is the use of this socket onto the upper pivot shaft of the feeder housing to manually rotate the feeder chain to dislodge any slugs. Another important header adjustment is header level. We want the knife to be equal distance on the left as well as on the right. This also puts the header level with our separator housing. To do this, we loosen these 4 bolts. With the aid of this draw bolt, we can force it forward, thereby raising the left end of the header. By moving it rearward, we'll raise the right end of the header. In the field, a quick and easy way to see if the header is level is take the main frame, separator housing, and see if these 2 lines are parallel with one another. The feeder and header engagement cylinder is located on the right front corner of the separator housing. The feeder and header is actuated by a hydraulic cylinder engaged with an electric switch, and when the unit is started, the upper line of this block should fall within that window. If the upper portion of the block falls within that window, that is properly adjusted. Whenever we're working in and around our headers, we always want to put the safety stand down. There is a convenient D-ring underneath the shield which holds the safety stand in the raised position. I pull the D-ring out, allowing the safety stand in place to go down over the cylinder rod, holding the header up. With our header raised and the safety stand in place, we're going to go underneath the feeder and header to adjust our header latches, one on the left and one on the right. Underneath the feeder house, we have header latches which need to be adjusted so that they have 40 to 50 foot-pounds of effort to latch them. Now we're going to go up to the service deck and show the separator engagement cylinder and the separator belt tension adjustment. Underneath this door is the separator engagement cylinder. To correctly show belt tension, we have a gauge, also a window within the gauge indicating that when the square mark on the block is into the window, the belt tension is proper. To correctly adjust the belt tension is done by adjusting the nut on this adjusting bolt. We're going to show further use of our cylinder rocking wrench by attaching the chain to the end of the rotor drive so that we may rock the rotor for clearing a slug. A word of caution before getting into the engine compartment is to be sure that the engine is not running. Now with the chain wrench attached to the rotor drive assembly, I can rotate the rotor, clearing the slug. Continuing on with our separation in the Axial Flow Combine, we have a unique feature, and that is located behind the feeder house and in front of the first concave, we have a transition cone. It's approximately 2 feet in length. Within this transition cone, we have impeller blades and directional vanes. This transition cone is used to remove the material from the back of the feeder house, accelerating it, getting it up to speed so we can thrash it as we get onto our concaves, spreading out the matted material, thinning it, getting it ready for separation. Also, we want to stop here for a second and think of rotary separation or rotary thrashing. You might think that 24 inches is quite a length in space, but in rotary thrashing, it's a little bit longer than that because it's starting to go into a circle. And on a 1680, for example, if we should open up this same transition cone, the material, as it came from the feeder house, the impeller blades start to carry it through the transition cone. It will travel approximately 6 feet. This is a little bit different than the conventional machine. The older conventional machines, the material, as it comes up the feeder house, is traveling approximately 5 miles an hour. As it hits its 20-inch cylinder, it would probably have to speed up to about 60 miles an hour. It's like a bug on a windshield in an automobile gets hit. Here in our axial flow, we begin to take the material away from the feeder chain, pull it into our transition cone, accelerating its speed and getting it up to proper speed, and our mat of material flow coming onto the concaves for better threshing, more even threshing, and better grain separation. And in this area we begin to get the whole kernel quality concept. Continuing with our threshing and separating story within our rotor cage, we're going to talk next about the concave sections, of which there are 3. 1, 2, and 3. Showing here laying on the ground are 2 different concaves. The first one being the small wire concave for wheat and small grain. There are 3 in the separator housing. Next, the second concave showing here is our large wire concave, mainly for corn, rice, and milo. Large wire diameter as well as large openings between each wire. In the wheat harvesting areas, some of our friends will take and remove 2 small wires from the number 3 and number 2 section in the separator area so that they get earlier separation once the grain is threshed, for example, if it was easy thrash. Also, if we got into some edible crops such as lima beans or kidneys, we would want to remove the small wire concaves, all 3 of them, and put in a set of large wire concaves, again, 3 each. If the bean or the seed is rather large in some of our unique seed crops, we may find that we have to pull every other wire out of a large wire concave, increasing our opening for better separation and reducing our grain damage, once again approaching the whole kernel concept into our grain tank. Continuing with the separation process in our axial flow combine, we're going to talk about separator grates. We have 3 of them located in this area. One here, which we call number 1, 2, and 3. In small grain harvest, we use a punch grate design. As you can see also, there is a bar laying in the middle of the hole. If, for example, we had some rotor loss, we may take these bars off, place them between the holes, or in the toolbox in the cab. If we need to fluff the crop a little bit to add to our separation, get the kernel out of the straw, we can take these same bars, put them on the inside, either over the hole as you see here, but on the inside, and as well we can place them between the holes. Also in small grain, such as rice and milo, we have keystock grates, which are standard equipment. As you can see by its design, it's much more open, adding to our separation. But at the same time, it does fluff the crop so that we can get better separation in the separating grate area. Also may add that this grate is our standard grate for our corn combines. Continuing with our grain separation, we're going to talk about the cleaning system. We're going to talk about the chaffer sieves and their use in connection with our cleaning fan located in this area. The chaffer sieves set in a separator housing along this line shown by my stick. What is the purpose of the chaffer sieve? Simple language, a chaffer sieve is an apparatus to control air, as well as control the amount of material that can pass down through it. While it's controlling this air, the chaff mat that has come down from the rotor housing is passing over this sieve. We try to keep the heavier particles airborne as well as the chaff, and since the grains are usually more dense than the straw or chaff particles, they will settle through this air current passing through our veins. Showing here is the grain sieve, 1 1/8" spacing, which is measured from the tip to tip of our veins. Also in the same system can be placed a corn slat chaffer sieve, used mainly in corn, or large seeds such as edible beans, being kidneys or lima beans. As you can see, the difference between the 2 sieves, the one that we call the corn slat sieve is more open, allowing room for larger seeds and more volume to pass through the veins. Our third chaffer sieve is our option 1 5/8" tip-to-tip measurement of a closed slat. This sieve is basically used in our milo harvest. The vein design is much the same as we saw in our grain sieve, with the exception it's wider spaced. Basically, we have 2 vein designs in the sieve system for our chaffer sieves. The upper one shown here depicting our grain at 1 1/8", the option at 1 5/8". The standard corn is a deep slat, as you can see the comparison of its fingers, spaced at 1 5/8". And now let's go on to our shoe sieves. Our shoe sieves are located in the lower portion of the cleaning system. Follow on this line as I show here with my stick. What is the shoe sieve's purpose? The shoe sieve's purpose is to do the final separation of chaff, unwanted particles in our grain. We want the grain to fall through, walk out the unthrashed portion of heads, parts of sticks, straw, chaff, and whatever. Again, the shoe sieve also controls air, helps get out the fine particles of chaff and walk and move this material to the rear of the sieve. This design is used generally for all crop conditions, but for the operator that wants the ultimate and may want a little more higher capacity, we offer an 1 5/8" closed slat design. This design is similar to what we saw earlier in the number 3 chaffer sieve. So basically the design of the vanes for the shoe sieve is the one on the top is a general purpose and is used in the majority of our crops, whereas particularly in corn or large seed crops such as a large edible bean, we would use the lower vane, closed slat, with this finger design. What we're showing here is a chaffer vane adjustment. We can use a scale to aid in telling us the gap between the finger and the trailing vane, or we can use 1/4 inch bolts, 5/16 bolts, or 1/2 inch bolts. In the operator's manual, we describe the opening of the sieve as I'm showing you here with this scale. The shoe sieve located below the chaffer sieve would be adjusted in the same manner. The concave adjustment is made with this ratchet to raise or lower the concave. To help us identify its position, there is an indicator out through the door, decal template showing us its position. Most generally in wheat, easy thrash position for indicator is sufficient. If we should get into hard threshing wheat conditions, such as pinched or dry kernels, still locked into a head, we may position up into a hard thrashing position, not only for wheat but other crops as well. Shown here are 3 wheat samples that are typically seen in the wheat harvesting area. The first one has particles of unthrashed heads in it, indicating that the shoe sieve's probably too wide open. Also, we may have our chaffer sieve too wide open and overloading our shoe. We also may help this situation by speeding up our rotor a little bit and also closing up the concave. Our second sample is a sample of wheat showing light pieces of chaff. The heads are not in there as we saw in the first sample. Gives us an indication that we have thrashed it and separated it quite well, but we need a little more wind. We do not have any large particles ahead from maybe the shoe sieve being too open. So again, maybe all we have to do here is increase our fan speed, be to an acceptable sample. A third sample is what we typically like to see coming from our combine. No chaff, no unthrashed particles. The grain quality is quite good. No cracks or splits. We like to take this sample to our elevator. Before we start to cut small grain with our combine, we need to know where some of our switches are located in the cab for helping us control the action of the combine. One of these is a separator switch. On, off, and to engage the separator, we need to lift and push forward, the safety feature, as well as the feeder switch located to the right of it. Has to be lifted for engagement. To raise and lower the header, the switch is located in the SR lever, which controls our forward motion and reverse. Next, we have a reel speed, slow, fast. Also, if the combine is equipped, and as an option, we have hydraulic fore and aft, and also automatic reel to ground speed. A digital tack, 4-pad position touch control, giving us engine speed, ground speed, rotor speed, fan speed. The rotor and fan speeds are increased and decreased by these 2 rocker switches for fast or slow on the rotor, as well as fast or slow on the fan. As we prepare our machine to harvest small grains, one of the first important things we should be looking at is the operator's manual. In the operator's manual, we have a chart for various machine settings as we prepare it for crops, one of which may be wheat. Our machine settings, for example, of wheat, rotor speed will be 1080, the rotor gear case set in the high range, concave set at easy thresh, suggestion of use of small wire concaves, 1/2 inch setting for the chaffer sieve, 1/4 inch for the shoe sieve, fan speed at 850 RPM, and the use of slotted grates. These are guidelines to get you started. You may vary either up or down from the suggested RPMs or measurements shown here. We've had a box placed under the combine as we drove over it, and what we're doing here is collecting the straw and the chaff as it came from the separator. Now, to complete this, we did remove the straw spreader such that we could get all of the grain, chaff, and straw particles to fall into our box. Now, the box can be the width of the separator or wider. In the case here, it was wider. In beginning to collect your sample, you want to collect what fell on top of the box because it is a foot in length, front to rear. Left to right, it was 4 feet. We take the straw that was collected immediately on top of the box and divide it from the rest of the straw that was next to it, either from the front or the back. If need be, spread it across the width of that collector. And as we begin to look at the sample, what we're looking for is unthrashed heads, basically, because they can count into your losses, meaning incomplete threshing. You may need to close your concave up, increase your rotor speed, or maybe it's just too tough. Now, remembering as you're going through this straw, there could be some loose kernels in there, so we start to fluff it, working the kernels such that they'll work down into the box and be collected. Getting rid of the straw, heavier particles, and always be watchful for a head that may be containing some grain or looks like it's unthrashed. Now, as we've gotten rid of the heavier particles, we begin to shake the box, getting the particles of grain down on the bottom side of the chaff. We're kind of wind fanning here to get rid of the lighter chaff particles so we can begin to see what our grain loss is going to look like, looking for those whole kernels. Okay, with our grain box constructed like you see, there's a little hole over in the corner of the center sections, and it allows us to work all the grain particles down into one area of the box. So they can be collected, counted, or weighed. Now that we have separated the good kernels of grain from our straw particles and chaff, we can begin to count the kernels that was collected in the box. Now, remembering that this sample was collected from the width of the separator. In the operator's manual, per the seed being checked for losses, there is called a loss chart. This loss chart can be compared to the width of cut as well as the combine size, whether it be a 1620, 1640, 1660, or 1680. These kernel counts are shown in 1 square foot increments. Each seed size has its own kernel count per square foot. What we're showing here is header loss. What we have done is taken the machine and cut a distance going forward, stopped, shut the header off, raising the reel, raising the header, and backing up. We're going to take the loss box that we use for our separator to mark off an area in the stubble so that we can collect any loose kernels that may be laying in that marked area. Inspecting the stubble, look for any loose kernels within the marked area. Collect them, throw them on your screen. Now remembering, when we're checking this sample for loss, this loss is per square foot over the entire acre. This should not be confused with how we collected our loss directly behind the separator. There we gathered in the width of cut, squeezed it down to the width of the separator. Here we have the full width of cut to check for our kernel loss. Within the operator's manual, there is a number of kernels shown that will give you per acre loss at the header. Not only do we look for loss behind the separator at the header, but walk out into the standing grain and look and see what might be laying on the ground, because Mother Nature can play tricks on you too. A small hailstorm, heavy rain, and so forth can shatter wheat. If wheat is pretty ripe, it's readily shattered and it can drop onto the ground, thereby adding to your loss that you collected for your header or the separator. Here I found several seeds. We're going to take a few moments now and describe a combine kill stop. What that is, we take the combine into a field of wheat, drive it at its normal adjusted rate, which could be 2.5, 3, 4 miles an hour. And as it's going through the wheat, it's established in the wheat, we will take the throttle, reduce its speed, we will take the brakes and the hydrostatic drive lever, and all three will be used to reduce the machine to a stopped condition. And as we do this, we want to do it in as short a distance as possible, thereby getting the material that's been collected in the machine to settle down onto our sieves, for example, so that we can go in there and look at it later. Now, while the machine is being run, it's a little difficult to get in there and see what the chaff patterns look like and where our grain loss may be. The moment after we've stopped the machine, we want to restart the engine, which will dissipate the heat that was collected in the engine. Also, that will let the dust settle out of the machine so that we can go back and better view the insides. Not only will we be looking at the cleaning system, but we're going to be looking at the concaves and our separator grates. Once we've completed this inspection, we're going to restart the machine, and as we engage the separator switch, we're going to set the throttle at about half speed. This will give enough torque to the engine so it won't die. It will also be slow enough that it won't bother the torque of the belts, get our rotor started. Once it begins to move, we will take and increase the throttle speed slightly and then come back to something just above low idle so that the grain that's been collected inside the machine is not thrown out the back. We want it back up in the grain tank. We're going to look in the cleaning system and see if there's any problems in here. What we're doing here now is taking the loose straw that fell off of our discharge beater chute, taking it off the cleaning sieve, chaffer sieve, exposing the chaff load that was on the cleaning system when the engine was stopped. Gives us an idea of what the chaff mat looks like while the machine is going through the field. If we have a cleaning system loss, there may be kernels in this straw back here, so we just pat it and see if there's any kernels can fall through onto the cleaning system. Some of the lighter sounds you hear now are just pieces of straw. If it's kernels, it'll be a sharp, ringy sound. Then if we're in doubt, we'll grab a handful of straw, look at it, looks good. Also, while we're in here, we want to look at the bottom of the beater pan. Look for any kernels that may be up here. Hopefully we find none. Further checking our combine after a kill stop, we want to come over and look at our tailings elevator, lower door. You open it up. We want to look at the texture of material that's in there. Gives us an idea where we may want to further adjust our sieves, chaffer and shoe, our fan speed, and also maybe our rotor speed, concave clearance. Maybe the pieces of head that may be in this sample are too big. We need to thrash them right the first time. This sample here indicates that the shoe sieve is a little bit too tight. We have too much thrash grain going back into our return. To further investigate our kill stop, we're going to go into our separator grate area. And look at the texture of material that's in our separator grate area. What we're going to be looking for is to see if we can find any loose kernels back here. Hopefully we find none. You may want to do it 2 or 3 times to make sure you've tickled the straw, as we call it. See if there's any kernels in there. Proceed on up into the second grate. Hopefully, again, we find none. But there may be 1 or 2 kernels there, of which I wouldn't be alarmed of. As we're getting up into the number 1 grate, the straw is a little more dense, and we're liable to find a few kernels up here. Don't be surprised if you find a few. This particular sample, we saw none. If we had a large amount of grain, such as may cover my hand, we would go further into the combine and go up into the concave area. Now that we've taken the concave inspection door off, this will allow us to get into the concave area, checking the straw, its density, attitude of the kernels, density in number 2 as well as number 1. As we get into number 1, that concave will have seen straw much the same as it came off the cutter bar. It's starting to thresh it, remembering that we work with our rotary threshing action. As the straw continues on to the second concave, we're going to have further threshing and our separation begins. As we get into number 3 section, now it's pretty much a separation function. Remembering what I said back in the grate area, we may have seen a little bit too much loose kernel on that first grate. There's a combination of things that we can do to affect that, and that is put different combinations of concaves in here, such as removing the small wire concave, which is predominantly used for small grains, and putting a large wire in its place. What this does is that once the grain is threshed, we need to separate it as quick as we can, get it into the auger beds, back into the cleaning system, thereby relieving the load of separating as much grain as we saw back there in a grate area. In some cases, in a custom cutter, people will put also a large wire in the number 2 section. And what they're looking for is earlier and earlier separation within the separator. For example, the wheat that we're in today, be to our advantage to have a small wire in number 1, a large wire in number 2, as well as a large wire in number 3. With this setup, the small wire has done our threshing, the 2 large wires will do our separating, thereby relieving the separator grates from having to do the excess separating of the loose kernels. Also, in our rotor cage, we have directional vanes, which can be pitched rearward or forward. And what they do is, if the vanes are in the forward position, for example, this speeds up the flow of material, or also speeds up our threshing. If we retard the vanes, this slows it down, such as if we were in a green, tough, hard threshing, hard separating grain. We can move them in unisons of 2 throughout the separator cage. We have vanes over our concaves, also we have vanes over our separator grates. They are adjusted by loosening the bolts, of which there are 3 on each vane, 6 each per 2 vanes. And we can move this plate fore and aft. Now that we have completed all the necessary adjustments in our combine to harvest wheat, let's go cut some grain.